welcome. Thanks for being here, everyone. Again, my name is Merritt Bear, and thanks, Merritt, for the introduction, and thanks for having us. This is my colleague, Aws Magnuson. We are going to start off talking a bit about kind of level setting about what AI is and what ML uses we're talking about. Why cloud is a factor in what we're talking about day to day. And then we're going to hand over the mic to my colleague Matt, who's going to get into a demo showing how some of what we consider to be AI services are really wound into the fabric of what we do day to day.
Should be ready.
Just getting our AV together here. So as Mary mentioned, I'm a principal security architect. I have been in AWS global accounts for the last 2 years. That's like the Fortune 100s around the world. So healthcare, automotive, oil and gas, manufacturing, high tech, etc. So advising on security and including AI/ML considerations, which, as I will talk about, are also part of the security offerings that we provide, as well as the capabilities that you can build out as a customer. And I'm now in a strategic role, so including public sector, and invite you all to come, introduce yourselves after. We're happy to take conversations about what your use cases are, and to be interactive throughout this session. If you have a thought or a question, feel free to raise your hand, and we can weave in some participation here.
We're getting so close.
Yeah. Well, no worries. We can.
So can you reduce the
And we'll just get
resolution of your output?
strobe lights and a fog machine.
lie, I've never had to do that before. I'm not really sure what that. Let's see. I did send you guys a link too. I shared it with Mary. If it could, we could potentially just pull.
It was there for a second. Yeah.
Oh, right.
Cool.
Yeah, let's give it a try.
The projector just
Needed to warm up. Gonna buy it a Mai Tai.
Yeah, there we go.
Cool.
All right.
It is showing your full
It
screen.
is. Let's see. How do we change that back? All right.
Yeah, that's good. That's fine.
All right, I think we're there.
Yeah, cool. Do you want to do your introduction?
Yeah. All right. Hey, thanks everyone. Sorry for the craziness there. What would a presentation be if there wasn't some kind of IT snafu? But as Mayor said, my name is Aws Magnuson. I'm the West Coast Navy Account Executive at AWS. I've been in this role for the last almost 3 years, serving a few of the familiar faces in the room in the Navy's journey to the cloud. One of the very fortunate situations that I have is San Diego, where I live, is really the epicenter of the Navy's drive to the commercial cloud. The majority of the Navy's contracts are located there, and the majority of the Navy's workloads that have migrated into most commercial cloud service providers are located in San Diego. I think what's even more exciting, though, is we're seeing a significantly more adoption rate of applications that exist here in the Hawaii AOR, more around being able to do things for operational use cases for HADR and disconnected ops. So we'll talk a little bit about that, but really focus more in the lens of AI and ML today. And so looking forward to just hearing more about your use cases. Thank you.
Cool. All right, so this is a brief overview of kind of the roadmap of what we plan to talk about. So what is AI/ML and how does Amazon use it? I'm actually not talking about just like AWS, but Amazon.com as well as an interesting customer use case. Cloud services that use AI/ML, the way that you can deploy now and hand tools to your developers, and then being able to unleash those using the stack itself. So 40% of digital transformation initiatives are supported by AI. That number sounds kind of arbitrary, but we are referring to the ways that it can transform your customer experience. So you could be using things like Amazon Connect, where you're talking about call centers and automating the interactions. Business operations and logistics. Again, you can think about the kinds of logistics challenges that Amazon.com goes through. Decision making, so putting in learning networks and neural networks and having training data that allows you to make better decision making. Innovation, obviously allowing folks to build and deploy quicker. And then competitive advantage, of course, relating to, we'll talk about a couple use cases where we've helped folks to shave down development timelines in everything from healthcare to Formula One, in taking what would have been a really burdensome data lift and making it shorter and more efficient. Hayes, is there any way that I can see notes as we go? Or they're going to show up if we do them?
I wish I knew the answer to that.
This slide is just showing that because of the world that we live in, and at this point when people say big data, I say, can we just call it data? We're really talking about a new landscape where we have a ton of data, as you know. A lot of this may come from, perfect, thank you. May come from things like IoT that have, sensors and other capabilities to extract data unlike before, but we're also talking about the fact that with cloud, you have what feels like unlimited storage and then unlimited compute power to be running analytics. So when we're talking about machine learning, and then of course getting to AI being something that's like built on top of that takes inputs and creates itself in a more ephemeral way, what we're really starting with is data, and you're starting with the ability to train for better and better models. And that just requires a lot of the ability to both store and compute. So speaking to the need now to be able to use cloud, or I guess I should say just the capability that you get with cloud. Some of these are just inherently cloudy aspects that allow you to do big data work. So the agility of being able to spin things up and down, to try things without going all in, the ability to use services that are pre-managed and pre-packaged. We're going to talk a little bit more about that. But we have functionality for a range of business use cases, everything from connect for call centers and translate for localization of things like language, up to SageMaker, which is a managed machine learning service. So basically having developers have put in some of that basic work to be able, so that you can just put in your data and not have to train the model. Getting to insights faster, so getting computational power, basically. We're talking about CPUs that are optimized for high power computing. Scalability, so being able to spin up and down and not needing to guess your limitations. So, 10 or 15 years ago when folks were constrained by their data centers, you really couldn't just make a game time decision to run vast analytics on a data set that you were deciding to collect whatever in that cycle. Now you can be a lot more dynamic about your decisions about what kinds of data to collect and store. Of course, as the security person, I would say you're going to want to put in lots of consideration into what you hold on to and how you secure those, right? But functionally, you're not feeling the limitations of your own data centers. Cost, of course, is a consideration. Hayes was telling a story this morning in the humanitarian assistance context that folks who were doing hurricane tracking and trying to get predictive analytics from that realized that in a recent hurricane season that they weren't going to have the computational power, and if they had built it themselves, it would have been $3.2 million. They were able to do it in AWS for $9,000. So, we're talking about huge economies of scale here, in part because you're only paying for what you use, and in part because we have optimized instances for things like high power computing. So, AIML sounds super sexy, but in reality, it is actually just getting into the grind of working with big data sets, having the ability to do the kinds of dynamic work that you need, get the insights that you're looking for, and also have additional capabilities that you hadn't maybe thought of. So this is a question that I sometimes ask customers when I come in the room, which is, if you had access to all the data, I mean, like, yes, whatever questions are going on in your mind, like, yes, all of the data. If you had access to all the data and you could run unlimited analytics on top of it, what would you do differently, right? So part of this means that we should be thinking more concretely about what data sets we find useful, and less constrained by like, well, we currently collect, weather information. Well, what would actually be our ideal data sets? And is there some way that we could get that? Is kind of the first layer here. Like, shouldn't we be taking a step back and asking about the types of data that we might be able to access now? And then the second layer is, what kinds of insights could we be drawing from that? So we're talking about certainly, use cases that you're probably thinking through now in terms of immediate outcomes from data, over time, or trying to do predictive analyses that, might have taken longer before, you can do faster. But we're also talking about internal processes. So for example, your security team should be doing data lakes and doing analytics on top of those. So you could be taking the last month of traffic and looking at what your patterns are and drawing anomalies and being able to act upon those. We have a managed service that I'm going to talk about a little bit that does some of that. But the reason that we built it out is that it came from us telling customers to watch their flow logs for anomalies. And then we ended up turning it into a pre-built service. So that's kind of one example of how we have turned, best practices or operational guidance into something that's just kind of a pull out of the box service to deploy. So there's a cool article, for those of you who are into this, about the literal elephant in the room that AI researchers found that an algorithm that was doing really good work identifying a bookshelf and a couch and a chair, the minute that you literally put an elephant in that room, it just misidentified everything. It wasn't able to sort of do a double take. So in this sense, just remember that even your most advanced AI is not as neurally resilient as a first grader, right? So we're still talking about what limitations that computers have, thinking through what problems can be solved with these kinds of tools. And I think it's good to not get too, chicken little about the machines taking over, and to remember that on the end of all of these conversations are developer conversations. So these are tools that are constrained by humans. Sometimes the applications end up brittle because of that, right? So it's something to just keep in mind, ground yourself in the realities that these are data sets, and then humans kind of putting reasoning on top of it that then machines can carry out in increasingly complex and vast ways. But ultimately, this is not like some kind of panacea. We are piecing it together. We're getting more sophisticated. We're certainly able to do incredible scale and incredible kind of new applications because of this. But it's not just like a silver bullet where we say put AI on it. It's not a universal term, and it's not a homogeneous thing. Which of course is my plug for you to hire diverse development teams so that you get people who think differently, and can see some of the brittleness there and help you to preempt those kinds of faults and biases in the algorithms that humans inevitably write. So machine learning is happening today. These are some examples. AstraZeneca has been experimenting with ML across R&D. You see a lot of machine learning in R&D because whereas 10 years ago, folks were actually running through the development cycle, they now can use modeling and simulation. So you cut down your development timeline significantly. It also means that we are able to, one of the elements that allows for greater dexterity here is that you can label data, so you can have metadata and tags. you can allow folks to do increasingly complex analytics over time while still understanding like the visibility of the landscape of the data they have. So whereas, 5 years ago, you might have a data set that sat in basically an Excel spreadsheet, right? And once you used it, it wasn't tagged for other alternative uses. You can now recycle it because you can have metadata that allows you to dynamically change those tags or to be able to say, all right, I want to use machine learning to pull out text that has these characteristics or images that have these, that follow with these recognition images. So you can be reusing data sets in ways that were not easy to do before. Let's see. Digital Globe is a high-resolution Earth imagery site. So we spoke this morning a little bit about humanitarian assistance uses in cloud, but so these are some of the elements of cloud where you can be talking about from the kind of nuts and bolts up to the high-power computer elements. So everything from RoboMaker, which is allowing you to program things like drones, to take satellite imagery, and then to be able to compare, use recognition to do analysis of images to find humans or pets if you needed to, and then to be able to compare images over time to do weather predictions and other kinds of response analytics. So at some point, the satellite imagery actually is one of the common use cases that I think probably relates to some of what you're looking at doing day to day, and being able to have that uploaded and not be constrained by where your data center is. As we mentioned, we have backbone that can be portable that might be in the form of a snowball, for example, which is one of our portable devices that where you can store and use compute in the field. We have brought some there at our booth in the center if you are curious as well. The NFL is a big user of compute power. They're just talking about like the kinds of insights that they're trying to derive. They're using play analytics. They're storing tons of tapes of the games. And they basically use it to offer fans a better experience. MLB, we'll talk about Formula One in a little bit. So it has really transformed the way that sports, interact with their fans. And also, similarly, the way that C-SPAN and other networks allow you to interact with politics. Let's see. So thinking a little bit about what Amazon does themselves, right? AWS considers Amazon to be one of our biggest customers, and thinking through the kinds of use cases that Amazon itself has using machine learning. So we use deep learning on Amazon.com, of course. I'm sure you've noticed that when you go to Amazon.com, they make recommendations. That turned into a service that we call Personalize. So you can deploy that yourself if you have a use case for something that would take previous inputs and allow you to customize offerings to folks. There's a lot of potential use cases here you can think through. We use machine learning in the fulfillment process. As you can imagine, the logistics of something like Amazon.com are really daunting and interesting. They are, for example, products are not shelved according to similarity. So you don't just have like every vacuum cleaner on one shelf. They are housed in what appears to be kind of arbitrary ways, but it has been found to optimize like robot paths as they grab items, and then to be able to optimize the size of boxes as they go into trucks so that they fit together and don't shift in transit. So tons of lessons that we've learned, and we're constantly trying to optimize those. And the data that we get from an ongoing basis is what we use to continually feed those. So just interesting stuff once this is the like unsexy backbone stuff that we all kind of take for granted now as part of kind of the infrastructure of walking around in the world. But it is folks' job to think through how to optimize these. So Natural language, of course, with Alexa. How many folks have some kind of home device, an Echo or a Google Home? Yeah, so these are running our basic serverless Lambda functions under the hood. You can customize them pretty easily if you are curious. You can look up online. You can write your own scripts for that. But that also is kind of one of the core elements here is that you can automate that serverless Lambda function that runs under your Alexa is an automation. So, you've probably experienced some frustration, and then sometimes when Alexa gets it perfectly, there are, teams and teams of developers who are working on trying to train that kind of model to get it better. As you can imagine, it is hard to have the kinds of linguistic just day-to-day turn into something that you can measurably say, responds in any kind of human sense. So just really interesting problems, and then the ways that we can embed those into your interactions. Let's see. So what's different now, right? I think part of this, in some sense, you could always have conceived of machine learning, but this term really took on more life in the last 10 years. And I think that is in part because you have these tools and these capabilities with your compute these days. So whereas 10 years ago or 20 years ago, certainly you had to do it all kind of by hand, you certainly could have thought through training algorithms, and you could have, tested data sets and tried them over time. But today, you have a different experience as a developer. You have a much more tactile ability to just spin things up in an ephemeral way. So going from data centers to console logins. How many folks have logged into a cloud console? Cool. So a good number of folks, you're experiencing infrastructure as code. So it used to be that your, IT department or your security team or your whomever, frankly, it was also like your operational folks who do development, who might not have been in IT, maybe they were in your operational field-facing roles, had to deal with the fact of your constraints around data centers. So someone had to maintain the concrete up through those, racks and stacks of servers. These days with cloud, what you're getting is infrastructure as code. So you can build these kinds of services yourself by taking the basic components of storage and compute and database. You can build in automations, you can build in thresholds with triggers, et cetera. You can teach it to have anomaly detection or to have expectations and then give you triggers. Those kinds of things are just basic building blocks that you don't need to have pre-programmed, you can do yourself. And then, of course, there are managed services that get even more tactile with it. So managed services go up the stack in terms of taking code that developers have already put together that serves a particular function, and then you would enter your data and have it be able to process it, right? So what this feels like, in effect, is that you've got machine learning in the hands of just your everyday developer. Any questions? I feel like folks are in their post-lunch nap period. Okay. So this is an example of a service. This is called Guard Duty at Amazon. But you could have built this yourself as a customer, and also most folks who are doing security are doing some kind of anomaly detection that looks like some of these tools, right? So it is a managed threat detection service, and what it does is monitor unusual API calls, unauthorized deployments, and potentially compromised instances. So this is what it looks like, and you will get a traffic light basically of the findings. But under the hood, it's taking these inputs, which are not things that you need to turn on, VPC flow logs, DNS logs, and CloudTrail, which are API calls. And it's basically doing what you would want to do anyway, taking traffic, right? So VPC flow logs, DNS logs, and then CloudTrail is your API calls. So it's taking events that absolutely, first of all, there's no false positives, because these are all just events that happened. They may or may not be things that you decide to care about. That is for you to decide, your thresholds. but they are all things that happened. And then being able to detect anomalies. So part of this is basically just taking best practices where you would have told your security team to keep an eye out for this, and then being able to dashboard it in a traffic light kind of way. Some of the cool things that we are getting into is also getting to the point where you can do hunt capabilities, and that will be a next level of this. But what we're looking at now is basically, not waiting for the next action to occur, but being able to actually do predictive analytics, profiling deviations, right? One of the cool things that Guard Duty uses, but that you can be using as a developer off the shelf, is setting in thresholds for anomaly detection, right? So you can set your parameters. In some sense, machine learning is like statistics and data, and you decide what confidence interval you want, you decide what your parameters are, and then you can set your detection or your remediations or whatever actions you want to take as a result of having put those inputs in. Does that make sense? Yeah, cool. So I'm going to talk a little bit about some of the use cases that we're seeing folks use when they are, developing with AI/ML in general. So this is what we conceive of as the ML stack. At the bottom here are like frameworks and infrastructure. These are the kinds of things that developers would be building kind of from the ground up. 85% of TensorFlow projects run on AWS, for example. But we're talking about, really building from more of the bricks. And then as you get up through here, the ML services, and then to AI services where you're calling those with an API call, and they are in some sense kind of prefab so that you can be putting in your data set, but you don't need to have trained it yourself. So let's see. The bottom layer of the stack is really for folks who are familiar with machine learning, who are practitioners that are comfortable building at the framework level. So you're going to be training and tuning and deploying your own machine learning models. It's still a lot less burdensome than it might have been 10 or 15 years ago because you're working from building blocks that are a lot more dynamic, as we mentioned. But these are basically kind of building from the ground up. So it would then allow you to connect into other AWS services and to take advantage of all your speed and compute power. Let's see. We want to focus on some of the story around pharma uses. So this is one that has really transformed the market. So for example, with Celgene, the average commercial drug costs more than $2.5 billion to bring to market and 10 plus years to develop. And of course, this is in part because people were doing a lot of it by hand. So the ability to cut your development times down, and at this point, it says we can now train what would have been 2 months down to 4 hours. Again, it's because you're not playing out every scenario over those 2 months. You actually just do the modeling in sim to do the expected behavior. Then you can, maybe you play it out once and gauge yourself against it, but you don't need to be doing every manual output. The NFL, so 17 million folks are in person in an NFL season, but 180 million fans are watching. So what that means is that, over 90% are watching not in person. So they are streaming, they're getting, a week of NFL games creates 3 terabytes of data. So we're talking about huge amounts of data and compute here. The NFL uses SageMaker and does predictive models to predict results from the games. They're getting down to 30 minutes to be able to act on them. GE Healthcare is using X-ray technology and using machine learning to understand what's going on at the expert physician levels. So we're getting from generalized healthcare to personal health care to particularized medicine. So some of this is just the model itself changing. Supply chain is a huge one. Folks obviously in military are familiar with supply chain challenges, but of course it's near and dear to Amazon's heart as well. Convoy is a trucking company, and using ML, they optimize their driver schedule and do load balancing, capacity planning, pricing, and payments. Before this, there had been 40% of the miles that truck drivers drove were not with any kind of load on them. So they have now been able to optimize so that folks are wasting fewer miles. And then Tinder. I'm sure no one is familiar, but they are, as you can imagine, they're a huge compute user. We're talking about getting assortative matching, right? So every time you get a swipe, you're trying to match an algorithm there. And it's a huge amount of compute power. It's also using Amazon recognition. So because Tinder collects so little data about people, just has your location and your photo, basically, one of the things that they do on the inside is take information from the photo. So if you have a guitar in your picture, they then use that input to categorize you as an artistic person to match you up with someone else who might have a violin in their picture. So they're using recognition, object recognition from the photos to be able to get more information about people. Kind of interesting, and certainly at the scale that it's happening, of course, and you don't feel the lag as you swipe, kind of an interesting case study in matching. They are also doing matching based on how choosy you are. So if you are one of the people who just swipes, is right yes, I think. If you're swiping right on everything, these guys are like, is it? I don't remember. But anyway, the one where you're swiping yes, if you swipe yes on everyone, your sort of personal attractiveness score will go down. And you will be matched with other low-scoring people because their goal is just to get the optimal number of matches. So kind of interesting if you think about, the goal is to have an outcome where there's a match. So they can then flesh out the bottom of the scale with all the non-choosy folks out there. So just tell your friends if you want to, but kind of a fun story on using ML for matching. At the top layer of the stack here are the AI services, which are, again, they're accessed with an API call. They're intentionally easy. They are, things that are operating in the software layers of the stack. So we're talking about sort of prefab-y services that serve a particular purpose. So your developers do not need a lot of sophistication. They can just be pulling use cases directly. Let's see, so this includes things like voice of the customer, so call centers, automated service agents. I know everyone here is wishing that those didn't exist, but trying to optimize interactions so that we can actually have humans, take calls only when it's required. Multilingual support, we have services that do translation as well as text searching. Workforce forecasting and agent analysis, and then next best action recommendations, so doing heuristics on them. Some really interesting use cases involve using AI services for safety and security. Have folks ever heard of Thorn? This is actually, it started out as a Demi and Ashton project, and it's a nonprofit that fights child sex trafficking. Let's see, and they run on AWS and use recognition in some of the AWS tools. They got a 65% reduction in investigation time, which means that they're identifying victims faster and doing more of it. So they have used these tools to identify 5,894 child sex trafficking victims. So, really dire elements here that you can be using. They will use specific images. Looking for someone's specific face. But you can also be looking for characteristics in photos. let's see. Similarly, Marinus Analytics is a law enforcement tool that focuses on sex trafficking investigations. Ayala Credit, which is on here, uses recognition to quickly approve loans in emerging markets using recognition. And then Pay Later is a lending platform in Africa that allows you to quickly give out loans using recognition using an Android mobile app. Within this, top layer, as we're talking about AI services, we can talk about optimizing media workflows. So we're talking about the huge amount of folks using social media, for example, but also content personalization, recommendation engines, et cetera. I mentioned Formula One. They are a really interesting use case. They, during each race, there are 120 sensors on each car, and they generate 1,500 data points every second, so 3 gigabytes of data every second. So they're using machine learning models, not only, so, if you've ever seen a Formula One race where there's like the pit stop, and it takes fractions of a second or maybe 2 seconds to do, but it significantly impacts their drive time. So they're now using machine learning to be able to call back to their training deck and say, do I need a pit stop or can I push forward without one, right? And it's usually not a clear-cut answer. They're looking at 60 years of data, and when a driver was in this point in the race with these characteristics on their car, because their car has all these sensors, you can be looking at fuel and all these other, what were the outcomes, right? Did they make it through the finish line? Did they stop? And what did they factor in? So really interesting. They're using it to make game time decisions, if you will, or race time decisions. But they also have opened that up to the fans. So you can actually see them trying to navigate those decisions, looking at the sensors, being able to kind of crunch the numbers in real time, and then see whether they need a pit stop or whether they can afford to keep going, et cetera. So really interesting kinds of uses. I mentioned C-SPAN also. There had been a huge backlog of videos, including congressional hearings, very ripe these days, but being able to have Library of Congress be able to have accessible tagged data so that citizens could go watch or look up resources on congressional hearings. There was a huge backlog, but using machine learning services, you now no longer had to have a human watching every hour and saying who was on camera and what was said. So being able to tag that kind of data has cut in half the amount of time that they spend being able to get the labor for indexing those. Localization is obviously a huge factor when we're talking about translation and recorded call analysis. So considerations around language in particular. Now that we expect that folks are doing business all around the world, having the ability to do translation in verbal and in written communications. I've talked a little bit about personalized recommendations, but this is a really interesting set of use cases where we're talking about increasing the customer experience, but also, of course, getting business outcomes from that. So, folks get much more likely to make a purchase if you're making recommendations that are relevant to them. You've cut down on time that they're spending on your platform, et cetera. Workforce planning and other future business outcomes. Tons of benefits that folks are using machine learning models for. Again, you can be taking trained models to be able to just put in your data and get outcomes from these. And then finally, this is another security-related test case, but being able to protect folks from unsafe content. So, for example, Coffee Meets Bagel, which is another dating website, to lower the need for content moderation, they have automated a lot of that. So we could imagine using it, as you do your kind of content moderation for internal sites, or as you think through what kinds of things you'd want to prevent from being uploaded to things that you maintain. You can be doing automated versions of content moderation now, which reduce your downtime by a lot. It, of course, is going to be trained so it gets better and better at recognizing the kinds of things you're looking for. Part of this, of course, will always come down to kind of a cultural conversation and how to adopt these and think through what kinds of problems you could be solving with these kinds of tools. So thinking about how to create this loop, how to advance your data strategy and organize for success, part of this is just thinking through how do you integrate development cycles in new ways. How do you take advantage of AI/ML tools? How do you consider that this new landscape in which you do have a lot fewer limitations to the kinds of data that you're accessing? What kind of arms do you want to put around that? What kind of use cases are you envisioning? It's going to take a cultural shift for your organization to think through how they want to deploy this. And of course, maybe it means re-identifying business problems. That is it for me. We are going to move into a demo so you can see some of just like what it means to be deploying something that uses AI and ML on the ground. Thank you.
Make sure you guys sit up
Well, I
here.
guess I should say, any other, do folks have questions at the end? No? Everyone's just chilling? Okay. Well, feel free to come up to me afterwards, as I mentioned. We can talk in, more depth about something that you're thinking about or about any of these test kind of cases that we have pointed to. There's tons of interesting elements that folks have been able to do. As I mentioned, thinking through what makes sense to have a computer do is sort of step one here. But there are obviously really cool elements of the fact that when you do have computerized elements, you have taken out the manual element, which has constrained you in terms of time, but it also has constrained you in terms of errors and other things. So thinking through how you can best leverage that. Of course, this isn't really about workforce reduction or anything. It's really more about allowing your people to do what only people can do and outsourcing the kind of heavy lifting that computers should be. Yeah.
Regarding these tools, as far as DoD goes, are you pursuing the cybersecurity maturity model as individual services? So each one would have a different level, or are you talking as a whole with you approach CMC? I'm kind of curious. Some of them look like they'd be great to use.
And so to talk a little bit to that, so the way that all cloud service providers are accredited for DoD customers to be able to leverage our services is at the service level. So each unique service is looked at individually per the data classifications of both FedRAMP and DoD Cloud Computing Security Requirements Guide, which is a document maintained by DISA. So our services will be looked at for the purposes of Impact Level 2, which is publicly available, Impact Level 4, which is FOUOCUI data sets, Impact Level 5, which is unclassified national security systems, Impact Level 6, which is secret, and then by ICD 503 for the purposes of TS/SCI workloads. All cloud service providers would have to submit third-party authorization documentation to both the FedRAMP Joint Authorization Board and DISA for review at each one of those individual levels in every region that those services exist. So the reason that I say that is extraordinary scrutiny over the services that we have and the NIST controls that we have in place to deliver these services to you. What we see is an enormous appetite for the DoD at the moment to be able to consume AI and ML services across all the cloud service providers. Right? You're seeing things like the Jake stand up. You're seeing things like DIU with lots of really unique AI and ML services. You're seeing things like Project Maven, Enterprise Challenge that we'll talk a little bit about here at the moment. But all these services have tremendous value. I mean, I hope that you sit up here and you see things like if the NFL can put a bunch of sensors on players' pads to be able to predict Tom Brady completing a pass to Gronk at a 42% level in real time using real-time video sensor feeds. Right? Can the DoD make use of that? We absolutely assume so. So what we do is we submit these services for review, and then ultimately as the ability to provide them as managed services. So we do adhere to those programs. We also adhere to all other compliance standards like HIPAA and PII and PCI and SOC 123 and on. So depending on what your use case is, more than likely we have services at that data classification level. Really long-winded answer. Did I hit on what you were?
Well, CMC doesn't actually come out until
Yeah, and so you're right. I mean, that's accurate. So they've just released at this point a draft we would respond to. So the expectation is that we would meet the standards based on when that becomes official policy. But yeah, because it's not official at this moment, we go with FedRAMP and DoD certification.
Thank you.
Great.
Yeah, those would be obviously super relevant in terms of just being blockers if you have a compliance requirement. Of course, operationally, security conversations, are also welcome. In terms of just like, can we be using this for sensitive data? What should we be thinking about as we deploy data into these kinds of systems? We are folks up and down the data sensitivity scale are using these, including Amazon.com that has lots of personal data. So those are also, conversations that we can have about how to secure the kinds of work that you're doing, especially if you want to maybe build out some capabilities in addition to using managed services.
Any other DoD specific questions we have?
Or anything. Yeah.
Great. Well,
Okay.
now we'll hand over to you.
Thank you, Hayes.
Good afternoon. My name is Matt Carter. I'm a senior solutions architect with Aws Elemental. And we're going to get into some scenarios where we were working with NGA in particular over the last couple of years on an exercise called Enterprise Challenge, which was really largely aimed, these past two exercises were largely aimed at getting video to the cloud and processing that in real time. I don't know, maybe show of hands in the room, how many folks work with video in your space? Not a whole lot. Some, I got some head nods back there. And so one important step for them was migrating video to the cloud, because there's a lot of data centers out there that are pushing video across these systems for the IC and the DoD, and a coalition as well. And as another interest of theirs was, how do you take that kind of capability, once it's in the cloud, start bolting on other components like AI and ML processing to see what can be done. So this was an exercise, if you're not real familiar with it, it's performed annually, and it's an opportunity for us to showcase kind of the latest and greatest technologies in a simulated kind of battle space or scenario-based situations. So I'll go through that with you, and we employed some of the AI services that we spoke about earlier today with recognition and some other things. So I'll show you some diagrams, and if you have questions along the way, feel free to stop me. Again, if you're not familiar with Aws Elemental, and not a whole lot of people are unless you're in the video space, we're considered to be the video services arm of Amazon Web Services. So just think about anything that is video processing or video-centric from a professional kind of distribution standpoint. This is where Elemental is very good in what we do. And we started out as a software-based company, which was really important as we became an acquisition just a few years ago and embedded into the larger platform with AWS. So we've taken our capabilities in software. We write all of our own codecs. We're a US-based organization out of Portland, but we're wholly owned by AWS as well. We're a subsidiary. So what we did is we took all of our technologies and rolled them up into a number of services. We now have 6 media services that you could select from at the console. So just like AI services, and ML rather, you would be able to go to media services and take a look at what we can do for you for video. So video has been a very important component over the last couple of years. There's been a huge modernization effort of getting video not only from a digital format in the early times leading up to that first part of the curve in 1984, when really the first digital video was created. And not far after that, we had MPEG-2 systems that was allowing kind of an industry transformation to take place. You probably all remember one. Specifically not too long ago when the broadcast community migrated from analog style television to digital television as a new kind of ATSC standard that was released in North America. We moved past that probably in the early 2010 timeframe, getting into kind of streaming services, and this is what Elemental was very good at. In 2006, they saw the vision that a lot of folks were basically trying to get content to devices like this, and so they needed to figure out a clever way to leverage the internet and kind of unmanaged networks to deliver that content. And so I just want to give you kind of a brief history of where we've been and where we're going. Today is what we're seeing is that thanks to the kind of the proliferation of these devices and streaming technologies, HLS, MPEG Dash, some of those may be familiar to you, that we're starting to see broadcasters move to the cloud. And just like NGA was interested in moving kind of their broadcast operations, if you will, also to the cloud. And so how would we kind of take advantage of those technologies to implement something like that? Now, you're probably familiar with something that looks similar to this. If you're Amazon Prime Video subscriber, perhaps, there's Netflix and Hulu, others that are out there. Is what we're doing is we're taking these same technologies and we're bundling them in such a way or organizing them in such a way, because AWS is building blocks, right? We're services. So we allow you to take those services and organize them in a way to kind of create your workflow. And so what we're doing is we're taking these technologies and reincorporating them into a workflow that satisfies kind of the DoD and intelligence community. So very similar kind of streaming, moving beyond that traditional IPTV style broadcast distribution method into a new modernized method for video. So let's take a look at what deployment architectures look like with video and AI. So again, as I mentioned, AWS, lots of services to choose from. And so if you look at just the kind of the traditional video pipeline, starting at the contribution side, we have essentially video encoders. Video encoders typically reside, on the ground or near a sensor, or maybe in an aircraft or in a vehicle. But we have boxes that range from all different form factors and sizes, and these boxes, are just physical devices, but underneath it's software. Basically powering the platform. That allows you to send the video into the cloud through a contribution technique. And then these orange boxes that are kind of scattered out here just kind of highlight the media services capability. So what is unique about this is that as that signal kind of goes through the workflow, it's becoming a more modern stream. It's moving away from traditional digital broadcast and IPTV style delivery using heavy transport streams and getting into that streaming fashion, so things are becoming reliable. And there's a really important component when you start to add the AI/ML piece to it, is that when you modernize this video, it becomes what we call segmented file delivery. So instead of it being a continuous bit stream of UDP packets coming at you, is what happens is we start segmenting that into chunks. And I know it's a technical term, but it's actually utilized out there. So we chunk the video into segments that could be as small as 1 second, maybe even smaller in some cases using more advanced protocols. But the typical kind of chunking for commercial applications, like in sports, for example, would be maybe 10-second chunks. And because you want to be able to deliver these what are essentially files, video files, to the browser, and allow the browser to be able to stitch those things together. And it appears as if the video is just playing very smoothly, as if it's just one continuous stream. So that's kind of the modernization technique that we're employing. And then, so once you get your video pipeline built, you're delivering those files into maybe an Amazon S3 bucket, we can start applying other capabilities from something like SageMaker as an example, where you may train a model that looks for something in particular in your video, and being able to call that out. Now, for the exercise on the Enterprise Challenge, we didn't use SageMaker there. We used Recognition, and I'm going to show kind of what that looked like here in just a second. So just real quick setup for what we did at the event. So in 2018, this was the workflow. It was basically take video, move it to the cloud, and then send it to an analyst. But to do that, I also want you to add a few things along the way. I want you to make it web friendly. I don't want to have to buy a bunch of expensive decoding hardware. And I also wanted to see if, they wanted to see if we could add some AI/ML capabilities to it. So it was lift and shift and make it usable. So as the video comes into our systems, we have humans in the loop, but the idea is that we want to augment that analysis and provide not just like the obvious, like, oh, that's a dog. Like everybody knows that's a dog, or that's a car. Everybody knows that's a car. Well, there could be some models that you train that is just constantly feeding contextual, searchable information back into a database. So when you go back and you search for something, it's going to show you all the frames, right, that has that object in it. So it may not be useful at the here and now, but it could be useful, later in post-processing. So that was 2018, which was fun, and we'll show you the architecture on that in a second. And then in 2019, this past year in May, I have a couple blogs on this particular topic as well that we wrote about. And what happened here is that they wanted to take that same environment in the cloud from an enterprise perspective and move it to the tactical edge. And so if you come by the booth later today or tomorrow, take a look at what we've got there. I'm going to show you the demo here in just a second, but we're focused on this tactical edge because we're very mature up there in the cloud. We can do these things very capable up there, but what can we actually get more to the tactical arena? So that was the interest in 2019. So I won't spend a whole lot of time on this, but this is just the setup for video that was migrating. Again, on the 2018 exercise, we had an encoder on the aircraft. We were communicating to a ground station, ingesting that into a cloud as just traditional kind of transport stream content, and just simply delivering it to another location. Now, this was in North Carolina. The analyst site was, I think, somewhere in DC. And is what the customer told us is, don't change our video, just make it exactly the same. We just want to see if you could just take the video and move it to the right location, right? So we do a lot of multicast, and so they said, bring our multicast and deliver it over here and make it multicast again. And we said, okay, no problem, we can do that. So one service took care of doing that. But we said, that's not really that interesting for where you're going in the future. If you want to really embrace cloud, how do you start distributing this content to large number of people, the masses out there? And the way to do that was through these newer technologies with HLS, MPEG-Dash, and CMAF. And so we had to add more services to accomplish this. And so this is, again, a very micro services-based architecture where each box is basically part of a fundamental function. Media Connect, as an example, was an ingest service. It brings reliable contribution of the content from the ground to the cloud. That's its only function in life, really. And it can do some fan outs. As it's fanning that out, moving it across the flow, Media Live is doing our adaptive bitrate encoding. So making one stream of video that could be coming in at 5 megabits per second, segmenting that into multiple segments, but also delivering multiple profiles. So think about your disadvantaged users, the enterprise user. You may have content that could scale from 1080p down to a 480p. So there's lots of things that you can do from an adaptive perspective. Media Package allowed us to take that content, package it into the right format so consumable devices could understand what it is and be able to negotiate, from like an origin server perspective. How do you maintain a connection with the cloud to deliver the content down to you? Certainly we were storing everything in S3. We had Media Convert to do additional file-based transcoding techniques. We implemented, this is where the partner perspective is extremely important. That EC2 instance with all the dashed lines, those are API calls. So we're working with a number of partners that as they're building a video user interface, all the little clickography buttons that they're putting on their UI is basically just service calls, to these particular services. So just imagine how easy it would be that once you get, and I say how easy it would be, but we all know it can be sometimes a little difficult to set up these things. I don't want to oversimplify. But at the same time, for developers that are in the cloud doing this development work, this is kind of what they do. So once we have this video pipeline kind of already set up, how do we add the AI component to it? We already have video flowing in real time. We've got content sitting there in an S3 bucket. The web players down there on the bottom right are able to consume it in real time. They can go back. They can shuttle back and forth, that pause, rewind, fast forward experience that we all love, being able to take your finger and slide it across the bar. So it was just another API call. So in this case, we used recognition, transcribe, and we dabbled a little bit with SageMaker here, but mainly on the recognition and transcribe. We didn't have a whole lot of time because this was kind of a stretch goal objective. We just want to see what we could do just applying these particular services really to the bucket and understanding the content that was recorded there. We wanted, as an analyst, was consuming this content. Maybe they found something that was interesting for the 20-minute period. So they would clip that 20 minutes inside their UI. Again, using the service calls, they would clip that, move that into the S3 bucket. That would kick off a workflow to send that through the recognition pipeline. And then what would happen is recognition would say, hey, this is a fence or car and people. And so what happened is it started providing this information back to the EC2 instance. And in this case, that EC2 instance was also a database. They had a database under the hood. And it was populating that with just good text information. And of course, we could do transcribe and translate. So if we want to convert this to multiple languages, that was quite easy for us to add that piece on there as well. Here's what it looked like in 2019, just from a more of a tactical, perspective. We had our aircraft up here working with a number of partners. We had an encoder. The bottom left here shows our Snowball Edge cluster. So that was 3 Snowball Edges. We're doing a lot of different type of processing techniques, but there were 6 other industry partners that were part of this exercise that we brought along with us because, as I said before, is they want to take that cloud processing architecture that we just looked at and migrate that down to snowballs. Okay, the Snowball Edge is this ruggedized compute device with storage and compute. And they said, okay, we need a snowball that's going to do mapping applications. We need a so we're going to have a partner for that. We need a snowball that's going to do the process exploitation and dissemination. So we had multiple partners doing that. We were doing the kind of processing of that content, making it more consumable from a web perspective. So when you had troops or different folks on the ground, they were able to receive that through the wireless mesh network onto their devices. So we were doing that portion. And then we were layering in the AI ML piece of it as well. So we had a snowball specific for that, which had a GPU instance running inside of it. So we started kind of building this network, and it was very modular is what we were finding. And just before we knew it, we actually had this entire thing up and operational in just really a couple of days. And there was some, I guess, prep work that was happening, but really all the vendors met, a week prior to the DV day, prior to the exercise, where everybody came through to examine, to take a look at it, and just everybody was learning so much, from that particular exercise. So it was great working with all the folks, if there's some in the room here, on what we were able to do. And so, what did we learn there? Well, there was 3 techniques here that I've touched on a lot of these, but I'll just go through them real quickly, and then we're going to get to just a quick demonstration of this video content. But we were educating the community that you needed to kind of think about things in more of a contribution and distribution format. And so anything that's in blue there is a contribution, which means it's going to go system to system. Okay, so it's okay to use transport streams here. That's not a problem, but we don't want to take that transport stream all the way out to the edge where the consumers are, because it's not a very scalable protocol. So what happens is we go to a distribution format for that. Now on the contribution side, we employ different techniques that kind of protect the content. Different mesh networks have different error packet recovery techniques. So using things like RTP or RTP with forward error correction. There's certainly newer technologies that are more advanced for the ARQ. Basically taking a UDP packet, putting it inside of a TCP packet to make it reliable. So that was one technique that we said, look at how you're organizing your networks, and let's think about things in contribution and distribution formats. Adaptive bitrate. I touched on this for a second, but this is a video stream that would be coming in, and then that Media Live application or the Elemental Live application would look at that stream and say, okay, I want to segment that in 1-second intervals, and I want to make 3 different variations of it. So when I subscribe to the origin server, I'm going to pull what I can based on my bandwidth and my screen resolution. So this is a real simple technique. When you get into the broadcast side, the commercial broadcast side, we're looking at some of these content providers doing like 12 different profiles, ranging from 4K down to what iPhone devices and Android devices can support. So that's kind of how that method works. I know we've all experienced it with your phones, and if you've watched video online, you typically get something that's a little kind of maybe hazy, or not hazy, but a little soft, and then all of a sudden it pops in and it looks really nice. That's that adaptive technique kind of taking over. HEVC, if you're not familiar with this, high efficiency video coding, this is the latest and greatest iteration from MPEG. We should want to embrace this. And so what we're finding is that there's still a lot of even MPEG 2 systems that are out there today, and AVC systems that are out there today. So one really important thing when it comes to AI and ML is better image quality is going to lead to better results. Okay, everything's based on basically kind of prediction of certainty. So if the percentage is low with, if you don't have the best compression, we can raise those percentages scores up a little bit by, just changing out the codec. So that's just one area that, I want to call attention to, which, in this graph, it's showing that we're moving the same image quality we keep halving the bit rate. But if you had the bit rate, then you're going to get that much more image quality back, okay? So the fidelity is going to be better for your AI and ML to work. All right, so on to the demo. So this is what we're showing over at the booths. If you get the opportunity, please stop by and take a look. This is very similar to what we did for Enterprise Challenge. And so we have a sensor feed coming into a snowball edge. And we can connect it to the cloud, although in this case we're not. We're operating it completely autonomously. And on that one snowball, we have a couple of EC2 instances on it, one of them being the Elemental software, which is doing that adaptive bitrate encoding that I was talking about for the different profiles. We're storing it to the S3 bucket. So that is two purposes for that, is we can store the original format as it is, and then we can also store these adaptive formats and make that S3 kind of location as an origin server. So when you move further out to the right, when you have the clients that are subscribing to that content, we partnered with one of our AWS technology partners with Textron Systems, and they brought their application called CGO, which was deployed for Enterprise Challenge. And it runs completely in a web browser. And it's this process exploitation dissemination type system that allows them to bring the content in. They're doing, kind of integration with this back end that we've created, and being able to curate content based on search and what's available, what's live, what's file. Not just that, but from the video perspective, it's more than just video to the browser. They basically kind of squeeze it back and then put some intelligence around it with other information like the metadata, for example. We all love metadata in this industry, and nobody does metadata like this industry. And so they've figured out some ways to basically extract that metadata, show it in a timely manner, and then also kind of correlate that to mapping applications as well. So that's a very cool kind of technique. And then deploying this all the way to the far edge there, and just something simple as a browser. It really doesn't require anything complicated to do this. And certainly if we wanted to add more sophistication to this, we could talk about the AI and ML services, because we already have the video, it's already a file, so that's just another service that we would layer on top. So come by and take a look at this if you get a chance. So just kind of a mock-up OV1 here, but if you're interested in what distribution video may look like on your device, feel free to take it out and take a look at that QR code. And this is content that's live, that's being streamed into the AWS ecosystem. It's going through that long workflow that I was talking to you about. And eventually it makes it to our content distribution network, our CDN, which is CloudFront. And that's where it's being delivered to your device in this kind of web-friendly fashion. Now that's the raw video coming right off the origin, so there's nothing there that like the CGO that I was talking about before, but this is what they would consume in order to make that kind of environment complete. So I know that was a little bit of a departure from the AI ML, but this is just real use cases that we utilized with a customer that was interested in, before they could even think about AI and ML, how do you get the content or the data that they have in a modern fashion to allow you to do these advanced workflows? And so this is kind of what we brought them through. And this was, over a couple of years worth of effort, but overall it's been leading to some really interesting pilot applications for us. So, any questions? I'm happy to take any questions. If not, we'll turn it back over to Hayes. If I don't know if you have any closing remarks or anything, but.
No, well, I mean, I'll leave it open for questions for the moment.
Yeah.
Anything from AI ML technology with video feeds? Great. So then what we'll do now is we'll give everyone the opportunity to come by and chat with us. But what we want to really bestow upon you is the thought that these AI ML services that the cloud service providers offer as managed services are almost infinitely usable across different use cases. Right. So when you think, does AI ML apply in X scenario? It does apply in that scenario. I think internally we had a pretty neat push from our CEO recently where he said, explain to me how you're going to use AI and ML in your business. No is not an answer. So when you think of all the things that Amazon.com does, right? Logistics, e-commerce, inventory for other third-party providers, video, the Go store, on and on. AI and ML touches every single part of it. And then when you get to the cloud service providers, to be able to deliver security services. All of our security tools are 100% AI and ML driven. So when you look at things like anomalous behavior detection, that is an AI ML tool that can sit in your environment, review your network, and alert you, and even take action that you define based on its findings itself. So all of our products today that we deliver to our customers are AI ML based, and we encourage you to think about how your daily workflow can be benefited by AI ML, because it absolutely can. Great. With that, we appreciate your time. Thank you so much, and we look forward to talking with you afterwards.
Thank you.